Perfection is admired in engineering. When a design is optimized to exact margins, when efficiency is maximized, when excess capacity is removed, it is considered disciplined. If the numbers align, the design is approved, and rarely questioned. The logic is coherent. Less over-design reduces capital cost. Higher efficiency reduces operating cost. Tighter control increases precision. Nothing here is technically incorrect, which is why optimization becomes the goal, not stability. Perfection removes slack. Thermal cushion disappears. Flow flexibility narrows. Response damping reduces. Aging tolerance shrinks. The system still works, but only inside a shrinking window. And real environments do not remain inside windows. The disturbance is small, a thin fouling layer, a minor viscosity shift, a slight sensor drift. Nothing fails, but the system was designed with no breathing room, so small variation becomes instability, oscillation, alarms, trips. Not because the system was wrong, because it was tight. Design confirms calculation. QA confirms tolerance. Procurement confirms budget. Commissioning confirms specification. Each boundary is satisfied. Yet the system behaves outside stability. No one owns margin, because margin is not visible during approval. Perfect design is fragile design, not because it lacks intelligence, because it lacks forgiveness. It narrowed. Operating width reduced. And when operating width disappears, stability follows. Margins are invisible until gone. When they vanish, the system does not collapse immediately. It destabilizes gradually. And that instability is often mistaken for component failure. It is not. It is margin loss. Engineering, unfettered. Real engineering, no filter.